All right, Algebra 2, Unit 6, Lesson 3. We're going to be talking about performing function operations and compositions. So again, if you kind of look at what I have here, all that really means is we're going to take two functions and then we can do addition, subtraction, multiplication, and division. So again, looking at this, the function of f of x is 5x and the function of g of x is x plus 2. So just talking about combining those, it'd be a good idea to write these down. Pause and write these down. I'll do maybe an example here as well. So let's say that we have f of x equals 4x to the 1/2 and g of x equals negative 9x to the 1/2. And let's say I want to find f of x plus g of x, and I want to find f of x minus g of x. So to start, 4x to the 1/2 plus negative 9x to the 1/2. I do have the same exponent, x to the 1/2, so I can combine my coefficients. 4 plus negative 9, that's going to be negative 5, and then again I still have x to the 1/2. F of x minus g of x minus negative 9x to the 1/2. Same type of idea, but 4 minus negative 9 gives me positive 13. Oops. And then we also want to maybe talk about the domains of these two. They are all non-negative real numbers. Because again, we don't really have to worry about it as much when we're adding or subtracting. When we do multiplying and dividing, so let's do a separate example here. Let's say f of x equals 6x and g of x equals x to the 3/4. If I want to find f of x times g of x, and I want to find f of x divided by g of x, what I'm going to look to do is say, okay, I'm going to plug these in. 6x times x to the 3/4, which means my exponent rules tell me that I need to add them. So I'm going to know 6 times 1 is 6, and then I have 1 plus 3/4, which is going to give me 6x to the 7/4 if you keep it as a mixed number. So again, the domain of this one is all real numbers. We don't have to worry about anything. F of x over g of x, so writing it, we have 6x over x to the 3/4 equals 6x. Now I'm going to subtract my exponents, which is going to give me 6x to the 1/4 power. And again, just because I can't take a square root of a negative number, my domain, because again, I have this x to the 1/4 here, it's in between 0 and 1. So if I have a negative number here, I won't be able to answer it. So this is restricted to only positive numbers. For a white rhino, heart rate R in beats per minute and lifespan S. So heart rate equals R and lifespan equals S, and that's in minutes, are related to body mass, which is M, which is in kilograms, by these functions. So R of M equals 241 m to the negative 0.25, and S of M equals 6 times, again, scientific notation here, 0.2. Find R of M times S of M and explain what this product means. So first step is R of M multiplied by S of M, and then we're going to explain what it means. So plugging in what I know, 241 M to the negative 0.25 multiplied by 6 times 10 to the 6th, and then this has M 0.2 on the outside. First step is I'm going to, again, combine what I know. So I'm going to multiply this 241 with this is just a number. And then I'm going to multiply my M's because they have the same base, and I'm going to combine those. So we're going to go here, and we are going to do here. So let's say 241 multiplied by 6 times 10 to the 6th power. And then that's going to be M. Now, again, multiplying, because of this multiplier right here, I know that I'm going to add these exponents. So 241 times 6 is 100 or 1,446 times 10 to the 6th, M to the negative 0.05, because I added these. And again, to move it over here, if I think about if this is my decimal point and I want to go 1, 2, because scientific notation needs to be in between 0 and 9.9, anything less than 10. And then, so since I went 1, 2, 3 units over, I got to add it to my exponents. And this is going to be 6 plus 3 is 9. And then I still have M to the negative 0.05. So interpret this. Multiplying the heart rate by lifespan gives the total number of heartbeats for a white rhino over the entire lifetime. So this is the total number of heartbeats for a white rhino's lifetime. That's a lot of heartbeats. I think this can kind of help us. So this is moving into composition functions now. So this is the second kind of part of this lesson. Here. Composition functions. And so kind of how this works is we are going to take a function of a function. So if I look at this, h of x equals g of f of x. So first thing I'm going to look at is, again, I'm going to look at like the domain of f. And I say I've got this circle, and this is my input of f. And this is x. Here, let's move this. Input of f, and then I have x. So x is going to travel over into the range of f. And my input's going to give me my output of f, which we call f of x. So then I'm going to take my f of x. However, that same number, that answer for my f of x, is now going to become my input of g. So f of x is my input of g, and now this becomes my domain of g, which this is then going to travel over here and say, all right, this is now g of f of x, which is my output of g. And then, again, this kind of gives us our range of g. So that's kind of like a Venn diagram of what we're going to be doing, or a flow chart. Let's do an example, and it may help clear things up. So for example, let's take f of x equals 2x minus 7, and g of x equals x squared plus 4. And I want to find what is the value value of g of f of 3. All right, so first thing, again, I have g of f. So I need to work from the inside out. So the first thing I need to figure out is what is my function of f when x is 3. So if I go through and solve that, 6 minus 7, this gives me -1. So that's my inside part right here. Now I'm going to take my function of g, and every time I find a -1, I'm going to plug it in. So -1 squared plus 4. -1 times 1 is +1. So g of -1 equals 5. So the correct answer of g of f of 3 equals 5. One more example of those. F of x equals 4x to the -1st. G of x equals 5x minus 2. We want to find f of g of x. That's very similar to what we just did. And then we also want to find g of f of x. Okay. So f of g of x means I have to do g of x first. So I'm going to plug in g of x, and then, so g of x equals 5x minus 2. So now I'm going to write my f function, okay, my f of x function, but every time I see an x, I'm going to plug in g of x, which is 5x minus 2. So I'm writing this function, but every time I see this, every time I see x minus 1, I'm plugging this in. So if you remember, a negative exponent brings it to the denominator. And so as far as we can go, this is as much as we can simplify. So very similar, we're going to look at g of f of x. So now I'm going to say, all right, I'm going to write the function g of x. And every time I see an x, I'm going to plug in my function that is f. So 4x to the -1st. And then I still have minus 2. All right, so if I think about this, I'm going to say, okay, 5 times 4 is 20, x to the -1st minus 2. I know that x to the -1st can be rewritten as going down below. So 20 over x minus 2.